In this video, we will see about Moore theory for circular waveguides. So basically, in this derivation, we will derive for how the electric field and magnetic field behaves in a cylindrical fiber shape. When the electric field magnetic field gets passed in the cylindrical fiber, how the electric field magnetic field gets changed along with your cylindrical coordinates of your fiber along the z direction. So to find that one, at first we require a electric and magnetic field in a free space and how it behaves. So at first Maxwell equation they have derived that in a basic dielectric material they have taken a basic dielectric material with no current and in free charges. So we know this equation in the electromagnetic interface. We will study these things. So del cross E is a basic electric field and then magnetic field and then electric displacement and then magnetic field intensity. So for this one we have derived the equation del cross is equal to minus dou B by dou T, del cross H is equal to dou D by dou T, del dot D is equal to 0 and del dot B is 0, which we have derived already in the electromagnetic subject. So where epsilon is permittivity and where mu is a permeability. So we know the basic equation of vector identity. Del cross, we will be taking turn on both the equations of equation 1. So del cross A is equal to minus mu into dou by dou T, where in B we have substituted mu into H, where mu is constant we have taken as outside. So minus mu into dou by dou T into del cross H. So after this one, if we minimize this one, what happens means for del cross H is given by del cross H is equal to dou D by dou T. So we will substitute the del cross H value over here. So minus mu dou by dou T into dou D by dou T. So where D is equal to epsilon E. Where D is equal to epsilon E. So minus mu epsilon dou square E by dou D square. So I am using vector identity del cross E is equal to del dot E minus del square E. And then we know that del dot E is equal to 0 and del dot H is equal to 0. So this all are basic vector identities. So now we will equate this del cross E with your corresponding equation del cross E. So it's become where del dot E is equal to 0 and this term completely get vanished, which will be minus del square E is equal to minus mu epsilon dou square E by dou D square, where both the minus gets cancelled and del square E is equal to mu epsilon dou square E by dou D square, and likewise for magnetic field del square H is equal to epsilon mu dou square H by dou D square. So both the equations are called standard wave equations for electric field and magnetic field. So now we have found that equation for electric field magnetic field in a dielectric material in a free space with no current. So now we will send this both electric field magnetic field in a cylindrical fiber shape. So in a basic fiber structure, how it will be the core and cladding. We will be having core and cladding. That core is in cylindrical shape. So always it is because it is a cylindrical shape. In electromagnetic we comes to know that for cylindrical shape always the coordinates are r, phi and z. The cylindrical coordinates are r, phi and z. So you consider this as a core material, and where here you can see that the z direction and then r is your radius and where is your phi is your angle. So r, phi, z is your cylindrical coordinates. So when this electric field and magnetic field travel inside the fiber, how the electric field and magnetic field gets changed with your z direction. It propagates along the z direction. So when the electric field magnetic field gets passing inside the fiber, how the electric field magnetic field gets changed along with the propagation. So for that one we will derive that one. So cylindrical coordinates are r, phi and z. So electromagnetic wave propagates along the z axis. So electric field magnetic field. So that one the basic equation is E is equal to E naught r comma phi. So where this is the amplitude part, and e power j omega t minus beta z, where this is your phase gets changed, gets changing along the z direction, where omega is your angular frequency, where t is your time, and where beta is the propagation constant, and where z is your corresponding propagation direction. So along the direction, the electromagnetic field will keep on gets decaying. So that's why it's exponentially going on. So likewise for magnetic field, H is equal to H naught into r comma phi e power j omega t minus beta z. So we know that in basic for electric field, the coordinates are r, phi and z, and this is the basic matrix for your del cross E. So now we will cross multiply with your AR and with the A phi and with the AZ, do the matrix multiplication over here. So it's given by AR into 1 by R dot dou Ez by dou phi. So AR into 1 by R by dou phi into Ez. So likewise minus dou E phi by dou Z. So minus A phi into, you can see over here. So I have done the corresponding matrix multiplication for the del cross C. So we will get this equation. So and then from here we will take a R as a constant outside. So AR by R dou Ez by dou phi minus R into dou E phi by dou Z minus A phi into dou Ez by dou R minus dou ER by dou Z plus AZ by R. We have taken R as outside constant. So AZ by R into dou E phi by dou R minus dou ER by dou phi. So now this is the 10th equation. So now we will differentiate your corresponding equation 8, the corresponding electromagnetic wave which propagates along the z-axis with respect to Z. Because along the z direction your electric field gets changed. So at first we will differentiate this equation to find the corresponding electric field components. So we are going to differentiate equation number 8 with respect to Z is given by dou E phi dou Z is equal to E naught into R comma phi into e power j omega t minus beta Z into minus j beta. So now it can be defined as this as a E phi minus j beta into E phi. So similarly for ER is given by j beta into ER. So now we will take this value. So dou E phi by dou Z is given by minus j beta E phi, and then for dou ER by dou Z it is given by minus j beta into ER. So we will take both the values and we will substitute over here. In case of dou E phi by dou Z and in case of dou ER by dou Z, we will substitute both the values. So it's given by AR by R dou Ez by dou phi plus JR beta into E phi minus A phi in terms of dou ER by dou Z. I have substituted over here as a j beta ER. So this is your del cross E equation. 10th equation has been modified as like this. So now from Maxwell equation we comes to know that del cross E is given by minus j omega mu h, and as del cross h is the j omega epsilon E. So we can take this equation. So del cross E is equal to minus j omega mu h, where h is expanded as with your coordinates of R, phi and Z. So now we will equate all the coefficients of your del cross C. The del cross C is given by all the coefficients. So we will equate all the coefficients with the AR and AR and A phi and A phi and AZ and AZ. So the first equation of A is given by 1 by R, where this AR is a coefficient. 1 by R dou Ez by dou phi plus JR beta into E phi is equal to minus j omega mu HR. Minus j omega mu HR is given as a. Likewise, once again A phi coefficient and likewise AZ coefficient, which has been equal to your minus j omega mu corresponding R phi Z components. R phi Z components. This is your R coefficient and this is your phi coefficient and this is Z coefficient. So now we have find the corresponding electric field coefficients HR, H phi, Hz. So likewise we can do it for the other components.